the BatteReverse project is an European-funded project from Horizon Europe Framework. We are 11 partners, both research institutes and companies, working together for 3.5 years to develop new technologies and approaches and business models for improved reverse logistics of electric vehicle batteries. Here you can see some areas that we are innovating. One of the areas is the battery assessment. We are developing a new acoustic testing and machine learning algorithms for faster and more precise battery discharge and first diagnosis. Then also our partners are working on the new safety packaging for lithium-ion batteries to minimize the thermal runaway risks. Together with our research and recycling partners, we also develop new methods for human-robot collaboration to dismantle and sort battery components more efficiently. And all of that is also connected through the battery data space, which we are developing in BatteReverse project, which aims to streamline battery identification and to help share data between the stakeholders to improve the efficiency of processes. Just some recent project updates. Our partners from the Institute of Łukasiewicz recently they have almost finalized the as-is reverse logistics model, and we are currently still collecting data from various stakeholders. And the aim of this development is to prepare, let's say, a baseline, which will help us then to assess how successful our project developments will be in terms of shortening the time of various processes and so on. Then also we just started technical developments in the project in all areas, in the areas of testing, dismantling, packaging, and battery passport. And also on the occasion of this event, we are happy to let you know that also our community, so all of you, we are all over 200 members at the moment, and we are happy that this number is growing. And I hope with events like this, it will continue to do so. Now, let's get to know each other a bit better. We prepared a short networking exercise. First of all, please add your full name and affiliation to the Zoom profile. You can do it in the tab of participants. When you click on participants, you can click more and rename yourself, adding affiliation. Then when you do that, you will be invited randomly to a breakout room with 2-3 other people. And in the breakout room, please briefly introduce yourself and explain your interest in battery testing for reverse logistics. And after 4 minutes, we come back to the main room and to do another round of introductions. Welcome back to everyone. We hope you had valuable, good networking time. I guess also the time again was quite short, but don't worry, after the presentation and the panel discussion, we'll have a chance to continue networking. And now let us continue. Our expert speaker will be talking about various battery testing approaches. And what we wanted first to understand is what's your level of knowledge, first of all, in this topic, and also what are your backgrounds, so that our speakers and all of you can know what types of stakeholders we discuss with today. I will launch now Paul. Sorry, wrong one. I will launch a different one. Okay. You should now receive a notification to answer the poll. First, we're asking you, what's your background? What type of company you're representing? And sorry, someone, I think, closed the poll. So could you please answer the poll again? And to those of you who are co-hosts, can you try not to close it? Because I think maybe it could be one of the co-hosts. Now it's working. Perfect. Okay, let's wait 5 more seconds. Okay, almost all of you answered. I will end the poll now and share results with you. As you can see, most of you come from research, but also we have many repurposers, dismantlers, battery testers, all kinds. And I hope this will make our discussions even more interesting. And most of you answered that you have quite limited knowledge in battery testing, but also we have some experts and people with decent knowledge. And that's great a place to get more knowledge. And with that, I would like to welcome Nicolas Guillet from CEA to present for us the testing approaches for reverse logistics. The floor is yours, Nicolas.
Thank you. I will share my screen.
We can see the screen.
Yeah.
Please go ahead.
Okay. So, hello, everybody. I've been asked you to give a quick overview of battery diagnostic and some of the test methods we can use to make an accurate, relevant, and maybe as far as possible, rapid diagnosis of the batteries at the end of their first service life. So,
Nicolas, we cannot hear you. I think you turned off your microphone.
You're not excited about that.
yeah. Do you hear me?
Yes, now we can hear you.
So I've been asked to give you a quick overview of the battery diagnostics and some of the test methods we can use to make accurate, relevant, and maybe as far as possible, rapid diagnosis of the battery at the end of their first service life. So first of all, let me quickly introduce myself. I made a PhD in material science and process engineering, followed by the specialization in electrocatalysis. And in 2005, I joined the French Energy Commission. And I'm currently senior expert in electrochemical storage and conversion. So a large part of my knowledge is related to electrochemistry, electrocatalysis. And since 2013, I joined the INES team, National Institute for Solar Energy, which is a part of the French Commission for Energy. And my activities are mainly focused on energy storage and conversion for stationary applications. So there is my email address if you want to contact me. Next, I also want to clarify the order of magnitude of the cell we can study. So in the screen, you have got a single cell, which is a basic element of a battery. These single cells can be electrically connected in series and parallel to form modules, and the modules can be assembled to form packs. In concrete, in real term, practical term, in real life, in a phone, you have got one cell. In a bicycle, you have got a module. In an electric car, you have got some packs. That's the difference. After that, I want you to present, to have a look on the benefit of using battery after the initial use, such as in an electric vehicle, and use it for other applications. So you can reduce significantly the pollution and yeah. You can significantly reduce the pollution and the waste due to the reproduction of battery when reusing, repurposing, or recycling such a battery. But the main issue is to define if a second-hand battery still has sufficient in performance to be reused, or whether it's better to direct it toward recycling the materials it contains. And how can we establish a relevant and precise, rapid diagnosis of these battery cells?
Nicolas,
Yes?
I think your microphone is malfunctioning a bit. Is there a chance you can switch it to the microphone from the computer?
Yeah, we'll try.
Should be in the next to microphone icon. You can select a different microphone. No, we cannot hear you now.
Is it better now?
We can hear you now. Yes, please continue.
Yeah. So I don't remember where I was. So the most important things is to classify, to grade the battery that have got the most important capacity for remaining storage. But also we have to take into account the electrical resistance inside to estimate what if the battery has got sufficient power, and more important is to estimate the remaining useful life for each application on the second hand. And there is another important parameter, which is the safety of these second-hand batteries. So, and the state of the art, we have got several electrical and electrochemical characterization methods that are used to establish the remaining performance of these batteries. This can be divided in electrical, electrochemical, physical characterization techniques. So in electrical, you have got some things like charge, discharge, measurement by impedance spectroscopy, for example, measurement of the energy and Faradic efficiency. Electrochemical, you have got some techniques with which are very accurate. For the physical part, we could measure the deformation of the cell, also the thermal analysis of the cell, which is the temperature which is reached by the cell during operation. And we also developed in BatteReverse an acoustic method, which is based on the transportation of ultrasonic waves through the battery and interaction of the ultrasonic waves with the materials during operation. And finally, we can also add some numerical data which are coming from the history of the battery via the data recorded by the battery management system or an external logging system. Yeah. So for these methods are generally very precise. Indeed, they can be used to establish complete model of the batteries and study their behavior, their electrical and thermal behavior. But on the other hand, they are generally quite complex and time-consuming, with measurement times incompatible with a large-scale industrial selection process. It's generally few hours. Finally, they are often not very well suited to study. Yes, they are often very well suited to study single cells, but are much more difficult to implement on modules and even less so on electric car packs. And aspects related to the estimation of remaining useful life in different application is quite difficult. So all these parameters remain difficult to assess, and we have to improve that techniques. So the approach we propose in the BatteReverse project is based on a combination of several different characterization techniques. These methods are applied at module level, second and module level, and we carry out tests representative to different applications in order to compare the aging model and quantify the errors in estimating the remaining useful life expected. The most important challenges is to identify the characterization technique that are the most relevant, the most readily implemented on modules, and the most rapid to estimate the remaining potential of these second life batteries. The second part of the second approach we propose in the BatteReverse project is to develop high performance analysis tools to take into account all that data that can be very heterogeneous. We have got some temperature, some acoustic signal, physical measurement, electrical and electrochemical measurement, etc. So the aim is to propose predictive classification and indicators that can be used to estimate the life expectancy in different type of application on second life application. I will present some few results we obtained on second life electric vehicle modules using a combination of electrical and electrochemical characterization techniques. So we developed a relatively simple tool based on machine learning algorithms that enable us to make a fairly accurate estimation, as you can see on the right part, of the remaining capacity in meters of few seconds. For example, in 20 seconds, you could have an estimation of the capacity with an error of 2.5 ampere hour on a 60 ampere hour cell. And if you want a more accurate estimation, you can make measurement over 120 seconds, 2 minutes, and you obtain something like 2 ampere hour of error on this measurement. So this is an example. And the next step we develop in the BatteReverse project is to add information from complementary measurements. For example, is physical measurement, acoustic, deformation, and so on, and historical data to establish some simple indicators that allow us to classify, to grade the battery according to their suitability for different secondary applications. And we can also use this data to quickly reject faulty or unstable cells, for example. Finally, we will perform some edging tests on module scale systems that enable us to assess the accuracy of the models we develop for estimating the remaining useful life expectancy. So thank you for your attention. I hope I haven't been too long. And if you have any question, please don't hesitate to ask for the floor or to contact me directly. Thank you.
Thank you very much, Nicolas. And we will move the questions till after the discussion panel. And now I give the floor to Rose Gregorio for the panel discussion.
Okay, thank you. Let me just share my slides. Okay, can you see my slide? Can you see my screen?
Yes.
Yes, okay.
Yes.
Great. Okay, so welcome everyone to the panel discussion. Thank you very much, Nicolas, for that presentation. So before we start, I would like to introduce ourselves first. So I am Rose Gregorio. I am a Communication, Dissemination, and Exploitation Officer from EIT Urban Mobility Foundation, and I lead the communication and dissemination efforts of the BatteReverse project. So you have already met Nicolas. So now let's proceed with Guillaume Hebert. Guillaume, please introduce yourself.
Yeah. Okay, thank you. Hello, everyone. So my name is Guillaume. I'm CEO of MOBA, a startup that we have created like 5 years ago. So basically what we do is that we provide a battery diagnosis solution for the second-hand electric car market.
Okay, thanks, Guillaume. And the next panel speaker is Oscar Oteruelo. Oscar, could you please introduce yourself?
Yeah, thank you, Rose. So I work as an engineer in SEAT, the automotive company in Barcelona, belonging to the Volkswagen Group. And my specialty are the circular economy projects related to the production side. In one of these projects we are working currently is related to battery recycling and energy storage. So that's the reason why I'm here. I'm really, really happy to contribute in this panel.
Okay, so thank you very much. And now let's move on to our topics. So our first topic is understanding the need for battery testing. So let me start with asking Oscar. Oscar, Europe's new batteries regulation describes various circular scenarios for battery treatment: repair, reuse, repurposing, and recycling. Could you explain how OEMs might decide which scenario can be applied for end-of-life batteries?
Mm-hmm. Okay, so that's a multifactorial dependency. So first of all, we have to keep in mind the chemistry of the battery. So if the battery is NMC type, it might be a first priority to go to recycling compared to the LFP, because the NMC battery has a higher material cost. Second thing will be, our second factor will be the battery architecture. So For instance, if we have as Tesla a cell-to-car architecture, it might be really difficult to repair, to remanufacture, and that's the reason why this battery, the only possible route as afterlife will be just the recycling. So once it depends on the company. So if they had also projects related to energy storage and they industrialize energy storage, they can prioritize the second life. So 3 factors, as I said, short recap: the chemistry, battery architecture, and business model prioritization for each OEM. But all said, if you should you want to do energy storage, or should the battery can be repaired or remanufactured, whatever you need to do first is the testing. So that is the reason why the battery testing is the ground basis for every decision that you make, especially all along the logistic chain. And that's the big takeaway from this question.
Okay, thanks a lot, Oscar. So I have a question now for Guillaume. Your company offers battery diagnosis services. Can you explain what's the typical use case for your offer? And what types of clients are most interested in state of health evaluation?
Yes, so maybe let's start with a small introduction on the solution, how it works. So basically, we have developed a OBD-based solution to diagnose any battery of any electric cars in less than 2 minutes without any charge or discharge protocol. So the idea is that we collect data from the BMS, we analyze them, and we create a battery certificate to help second-hand electric car sellers to sell faster and easier by giving transparency to their buyers. So this is what we do, and we are working with companies that need to perform thousands of diagnoses each month. Basically, the solution is developed for industrials, so companies, big companies that have to conduct several tests, diagnoses in many sites, many countries, with hundreds of operators, and they need something easy, simple, and multi-brands that you can use the same way for each electric car, and that doesn't need a complex specific knowledge to do it. So basically, we work with remarketing experts such as OEMs, dealership networks. We work with Toyota, Stellantis, and others to help them to deploy a battery solution in every dealerships. We work with leasing companies that really need to assess the state of the battery at the end of the leasing period to be sure that the residual value of the electric car is as good as expected. And we also work with remarketing companies like Aramis Auto in France, for example. So companies focused on buying and selling back second-hand cars. So we are helping them to conduct this battery testing with the most efficient and easy approach. So this is really what we do, and the typical use case of the solution is for the industrial activities, industrial processes, and so on.
Okay. Okay, thank you very much, Guillaume. Okay, let's move on to the next topic, which is technical approaches to battery testing. So now I want to ask you, Nicolas, you presented several methods of battery testing. Which of them do you consider the most scalable for EV batteries? So, for example, can electrochemical impedance spectroscopy be applied to module and pack level?
Yeah, So there is no doubt that conventional electrochemical methods are essential to determine if the battery has got the performance to be used in second life. However, this is not sufficient. We experience this every day in your research lab, particularly during your supervised aging tests. There is a very large difference that cannot be explained with conventional electrochemical method. So combining different techniques, as I proposed in BatteReverse project, with the conventional method, is, in my opinion, something which is necessary to improve greatly the diagnosis. Concerning the impedance spectroscopy, it's a widely used technique, but it's not so easy to implement in complex systems such as the module, and even less on battery packs. So to use it, there is some progress to do, and I'm not sure it could be implemented so easily in packs. Mainly when the BMS has got some troubles, it appears that the BMS of the battery is often a defect in the battery module or battery pack. So in that case, it's not possible to use such technique, and we have to develop some tools that could be used even though there is no information on one type. For example, no information on impedance spectroscopy, but we have got some information from other parameters.
All right, thank you. And Guillaume, can you describe your technical approach to battery diagnosis and how it compares with methods based on charging, discharging cycles? What level of detail can you assess? Can you identify issues with specific cells or other pack components?
Yeah, right. So the first thing to understand is that with MOBA, we rely on the OEM state of health, okay? So the only one way that we can perform this 2-minute diagnosis without any charging or discharging the pack is because we rely on this information that has already been calculated by the BMS, which is the info on the battery degradation. Sometimes it's a state of health that has been calculated. Sometimes it's something like a degradation rate, a remaining capacity. There is so many ways to establish the actual state of the battery, so many approaches, so many way of printing them. So what we do is that we collect the right info that exists on the battery, and we use it, analyze it, complete it, put some other indicators to give more information on the battery, and we put it on our certificate. So the idea is that we think that all the intelligence has to be put it into the BMS by the OEMs. So because somewhere the BMS is the best way to calculate the state of health, is the only one software that has a full access of the historic of the battery. This is something very important, because if you conduct a diagnosis with, for example, a coulometry approach, so you will charge or discharge the battery, it will take hours or at least dozens of minutes. So the thing is that, as we wanted to have something really suited for the industry that only takes 2 minutes, we decided to stick on this info. The second reason is, for us today, maybe it's going to change, but today the only one info that the final consumer can use is the OEM given by the manufacturer, because this is the only one info that you can use for activating a warranty. So if you want to change, to repair your battery, you will need to assess that the battery state of health is below, for example, 75%. And the only one state of health used by the OEMs to activate this warranty is the state of health calculated by their own BMS. So for those two reasons, we rely on this info, but we can do many other things by taking this picture of the battery BMS. For example, we can detect if you have some fault cells by analyzing cells voltage. We can see sometimes if the battery presents some symptoms of degradation, if you have some cells that could be replaced in order to upgrade the battery, for example. So this is something that we have already done in the past, detecting some default cells and helping our clients to repair the battery by changing those cells. So taking a picture of the battery with the most simple approach and finding all the information, all the value based on this photography.
Sorry, I was on mute. Thank you very much, Guillaume. That's very interesting what you said. And I do have a question for you later about the OEM BMS. But first, let's go to the next slide. Oops, where is it? Here. Oops, here. OEM data versus independent tests. So, Oscar, I have a question for you. The EU batteries regulation states that battery state of health data should be available to consumers and economic operators through the battery passport. What would be the conditions or considerations for OEMs?
Mm-hmm. So let me start talking about the customer, the client, because this is why we are doing this. So the aim of having this battery passport is to give clarity to the owner, or the potential client for a new car or a pre-owned car. So that's really important because right now you don't have the guarantee what is the state of the battery. So this is one thing. The other thing is there are two things to consider in terms of the OEM. First of all, is you have to give you have to disclosure as a OEM information related to the battery. What are the composition, the chemical composition? What is the recycling percentage? Certifications of safety standards, environmental regulations. So, and that's the easy part. As an OEM, you have to disclosure a lot of information, but that's okay. So the difficult part is the second one, which is something related to what Guillaume explained before. You need to disclosure the state of the battery on the dealers before being bought by a owner. So here lies the difficulty, because you have to have, first of all, easy, fast, reliable test. And also this test has to be connected to the information database to be registered on the digital passport. So this is something that has to be created, and it has to start with an easy, reliable test that doesn't need a technician on the dealer. And I will finish this question answering that this is really important, because the next frontier for the OEMs is the mobility as a service. So we expect in the future short life cycles of the car, and at the end of each life cycle, for instance, one leasing, then you need one of the tests, and this test to be registered on the digital passport. So this is a big challenge ahead, but it is really worth in terms of the customer.
Okay, thank you very much, Oscar. Okay, Nicolas, my question for you is battery testing methods are becoming more effective and more accurate. In this case, is there any need to receive BMS data from OEMs? How can their data help improve battery testing?
So on my opinion, as I've already said, it's by cross-referencing different sources of information on electrical, physical, thermal, and history of the battery that we could make the diagnosis. The BMS is the battery management system, and maybe another type of object, a logging. A logger of the performance could be used not to manage the battery, but just to record what's going on sometimes in the battery. And that information could be used as a data logger, in fact, to make a better diagnosis. Because one problem is often observed in second-hand batteries is that the BMS is not usable at all. Because there is not the can, or because it's damaged, but the cells, the modules are still alive, but the BMS is not usable. And in that case, we reject all the batteries, whereas they can be used for a second life. So the history of the battery recorded during the operation is really, really important as a source of information for the battery classification, of course.
Okay, thanks. And so for Guillaume, the MOBA solution is certified by the Cara Battery Health Check Scheme. Can you explain what it is?
Yeah, thank you for talking about that. It's very important. In 2023, the first standard for battery diagnosis has been created by the CARA. So CARA stands for CARA Association Remarketing. Basically, it's an association that represents the interest of key players of the remarketing industry. So they have understood that the battery diagnosis topic will be very important in the next year. So they decided to create a standard to say, okay, a good solution for battery diagnosis should have this specification, and so on. So last year we obtained this certification. So at the beginnings, the CARA wanted to have an independent state of health calculation for many reasons that are very interesting, of course. But the thing is that they also needed to have this industrial approach. They needed to find a solution able to be performed in less than 2 minutes without any constraint for the members, because companies like, I don't know, Arval, they have to perform hundreds of car inspection a day, so they can't spend minutes, even dozen of minutes. It isn't possible. So they decided to create this first standard, the basic approach, that allows to rely on the OEM state of health. They understood that it was the only one way at the moment to stick to fit with the needs of the industry. So that was for the explanation on the CARA. Regarding the premium test.
So I wanted to ask you. So earlier you mentioned that you rely on the BMS data, right? But the premium battery health check requires that you do independent tests. So do you plan to offer this service as well in the future?
This is something that we are looking at closely, of course. This is something that we are already able to do. We have some algorithm that allows to calculate this independent state of health. The thing is that you need more time to do it. So we believe that maybe this kind of diagnosis should be used only for vehicles that need it. I mean, for the 99% of the vehicles of the battery that you will diagnose, they OEM state of health is quite enough. But for like 1% of those vehicles, maybe you should perform a more complete test to have more information on the battery. For example, if you have a OEM state of health that is obviously wrong, you may take the time, and it also depends on the value of the vehicle. I mean, you won't take the same time for a Tesla Model S than for a Renault Kangoo. So you have to really understand the needs of the industry to understand that it depends on the value of the vehicle and on the battery condition to take more or less time on the diagnosis. So to answer the question, this is something that we already are already able to do, this independent state of health, but our clients don't want it yet because they just want to have this 2-minute approach all across their process. Because for the market, for the final customer, the OEM state of health, once again, is the only one that can be used on for the warranty. So they believe, and we believe it too, that it's the only one info for now that have some economical value. So for now, we focus on this OEM state of health.
Okay, thank you very much. Okay, let's move on now to the next topic, which is, okay, why is my, oh. Sorry, what's happening to my screen? Here, okay. Okay, so let's go to the topic of local BMS versus cloud-based BMS. So Oscar, we are now hearing more and more about cloud-based BMS. What do you think are the benefits and challenges of implementing this for OEMs?
Okay, so the benefit is that we can have as a OEM recollect a lot of data that we can use to provide a better service for the client. For instance, preventive maintenance or preventive failure of the battery. So that's really good. And also we can use all this data to improve the design of the battery. So that will be the key point and the key advantage. On the contrary, there is a big drawback related to the cloud-based BMS, and it's the customer experience. So this is not a feature that you can use to sell more cars. This is not because, and let me be a bit provocative, the general and common client and customer doesn't appreciate that. So the client wants extras and features on the car that improve their experience. And this is not experience. This is not. So putting or having a cloud-based BMS on the car makes the car more expensive. And the client right now is not willing to do that. So Steve Jobs said that you have to think first on the problems that the client have and then apply the awesome technology, but not the other way around. And this is something similar. So this is awesome technology, but right now, why can't we use that? Not to deceive the client, because the client buys a really expensive car because of the battery and so on.
How to understand and read some path diagrams. Now,
Sorry, yep. So as I said, it will be implemented on, and also you have the BMS slave, you have the BMS master. The slave, you will need it with a cloud-based BMS, and also the master, in case you've got the cloud-based BMS, you will need also, for security's sake, also a master. So it doesn't really make the car cheaper, on the contrary. So in the midterm, when everything in the car is connected and there is an integrated SIM card on the car, yeah, but we have to wait a few years to be implemented on the car.
Okay, thank you very much. And Guillaume, is MOBA doing local BMS diagnostics or cloud-based? And as a battery diagnostics and certification company, do you see any pros and cons of either system?
Yeah, well, so what we do is that we have a local BMS approach. So we have a dongle that we use, an OBD2 dongle that we plug into the OBD2 socket. We collect data from the BMS directly from the car. And we use those data. We think that once again, the value of MOBA is to bring this multi-brand solution. So since all manufacturers won't enable third-party players like us to get access to these data from the cloud in the same time, we believe that our clients will always need a concrete solution that works for every cars they have to diagnose. So this is why we have this local BMS approach. It's because it's the only one way to ensure that it will work the same way for every brand that our clients will have to diagnose.
Okay, thank you. All right, let's now go to our last topic, the future of battery testing in reverse logistics. To all speakers, I want to ask you, in 10 years, what do you think battery testing will look like? What will be the most popular methods of providing value for Second Life? And what will be the role of stakeholders? Maybe we can start with Nicolas.
Yeah, thank you, Rose. I think there is different topics in different application. For Guillaume and Oscar, it's mainly to diagnose the battery during operation in first life, and be sure that the range of the car is sufficient. Finally, the customer at the end want to know the range of the car, how many kilometers it could drive. That's his opinion. For the BatteReverse project and for solution for Second Life, it's different. It's quite different because we don't care the capacity of the battery, but we want to know how many times I could use that old battery in that application. And may I guarantee? May I do a warranty on that battery or not? In order to reduce the waste of such type of battery and the reconstruction of the batteries, because there is some important problem with the recycling of the materials, such as graphite, such as iron phosphate materials, for example, because there is no huge value of that materials. So for the Second Life use, it's quite different than for the first use in a car, on my sense. And the future, I hope there will be some improvement in the estimation of the remaining useful life of the battery after dismantling from the pack of the EV cars, for example.
Okay, thank you very much, Nicolas. And maybe Oscar, same question for you.
So, okay, if we think in a future in 10 years, I will say that we expect the battery testing to be fast, easy operated, almost plug and unplug, and also with a cheap hardware to do that. So in terms of the logistic chain, the logistic chain of the batteries is complicated. It's a complex process with different stages. One will be the capillarity transport from one point, for instance, the dealer to consolidation center, and then from the consolidation center to the next stage of the battery, that it can be either the industrialization as a second life for energy storage or battery recycling or remanufacturing. So in each one of these processes, you need this fast, reliable test that can give information during all the logistic chain. So before you do something with the battery, before moving the battery, you know what is the next step, what is the next road, that's either recycling, energy storage, remanufacturing, and for that you need a test. And also in terms of security, is it safe to transport this battery, to put this battery in a truck or not?
Okay, all right, thank you very much, Oscar.
Thank you.
Same question for you, Guillaume.
Yes, so in a nutshell, I think that in 10 years, the good diagnosis solution will have to go beyond the state of health. I mean, establishing the state of health of a battery is very important, but the key question is about the actual value, the residual value of the battery. And it means, what can I do with a used battery? And it depends on its value and on its state. For example, one day, someone that has an electric car will ask himself, what can I do with my car? What can I do with my battery? Shall I sell back my electric car? Shall I repair or replace my battery? What can I do with this battery? Should it go to the second life market? Should it go to the recycling directly? So all those questions we'll have to find answers, and those answers have to be solved by the battery diagnosis solution. So basically, there is so many things to do based on the state of the battery, based on the state of health, based on the idea of how the state of health is going to decrease on the next years. So we believe that the good diagnosis solution has to answer all those questions, complex questions on the use of the battery depending on its states.
Okay, thank you very much, Guillaume. So thank you very much to our panel speakers. Now the panel session is over. We're moving on now to question and answer. So
there have been quite several questions in the chat, so maybe I will pick some of them for the speakers. First, Jose from Circular Valley asked Nicolas, regarding your proposed testing method, could you share a bit more about how you estimate the state of health and remaining useful life of your batteries, and if your machine learning algorithm plays a role in these estimates?
So for sure, the machine learning algorithm plays a role, of course, because we use several very heterogeneous data to incorporate and calculate, estimate, maybe via a model, not the state of health. For me, it's not the state of health which is important, because the state of health is an indicator of the capacity that in terms of rooms which are inside the battery, but in terms of usability in different applications. For example, there is some batteries that have got the very important capacity, which is close to 90%, but the internal resistance increased a lot because there is a swelling of the battery, and it can be used at higher CA rate, for example. So this battery could be used for peak shifting, but not for another application with high current required. For example, for UPS, for example, for say where you need high current. So there is an important the machine learning model we develop can combine different very heterogeneous data to estimate the remaining useful life in different applications. and we use some radial basis function type machine learning system or more simple. But there is different solution we developed in parallel.
I think this is quite linked to what Guillaume explained, that in the future, it's not only the state of health, but also the remaining value, like monetary value in the batteries that is there. And Guillaume, do you have already plans to, or do you already offer such, let's say, consultancy based on your testing to companies? What to do next? Because we know that there are some companies that try to follow this approach, of optimizing the value of batteries for any application.
Yeah, so today what we do is that we help our clients to buy and sell electric cars. So we help them to buy them at the right price by checking the state of health of the battery, so to make the right offer. And we also help them to reassure their clients through the certificate in order to sell faster and easier. But what we also want to do, and that we already do, but on the R&D part, we also want to help our clients to optimize the value of the assets they have, which are the electric cars. And to do so, we know that you have many operations that could be done on the battery to restore the state of health. You have some software operations that you can do. For example, you can reset the battery management system that can improve a little bit the state of health. You can have some hardware operations, such as cells or module replacements. So all the idea of MOBA is to give the good information to the clients to take the good decision, and it depends on the battery state. It depends on the battery value. It depends on the electric car value. So this is something that we are working on to help our clients to do the right choice regarding the battery revalorization. And we have already done it in the past. For example, we have been able to detect that a battery had some cells that was really used, and those cells that were really impacted by the aging had a bad impact on the global state of health of the battery. So we help our clients to detect this, and we send the battery to a partner specialized in the reparation of batteries to repair or replace as a matter of fact, the cells. So instead of replacing the whole battery with the OEM that cost something like 10 or 20,000 euros, they were able to just replace the right element for 1 or 2,000 euros. So yeah, this is really something that we are working on. This is something that we are starting to be able to do, but to do it at scale, and this is all the problem that we solve. It's a huge work.
And also, especially once we get more batteries with cell-to-pack approach, it will be probably more difficult to replace just one module, right? I've seen some batteries like in the new Teslas where you actually fill out the battery pack with polyurethane foam, which makes it impossible to do any repairs.
Of course, it depends on the battery itself. I mean, some batteries you can do it, you cannot do it.
And I think that it relates a bit to a question from Steven Lance. He asks, when state of health of a module has been determined as insufficient, how many cells are generally not good enough anymore, degraded beyond a certain point? So I understand this relates a bit to what you explained in terms of that sometimes you can still replace just specific cells or modules.
Yeah, I'm taking a look at the question, but if someone else wants to take the question. Well, regarding the European battery regulation, I think that this is really something good. I mean, for the market, the idea beyond this regulation is to really create the normative frame to bring those kind of solution to repair, reuse, recycle the battery. But all those operation needs the right diagnosis at the right moment. So.
Thanks, Guillaume. And I also wanted to ask Oscar, because quite usually when we think of battery testing and replacement of batteries, we assume that let's say if you're not happy with your battery anymore, then you try to replace the battery. But well, the internal combustion engine vehicles, if you're not happy with it, usually you just sell the car, and probably electric vehicles will be also sold to another customer that will be happy with it, right? So it's not necessary that you have to replace the batteries. And my question is, what will be the role of battery testing in these in such situations when you actually sell the whole car? Do you think this will be, just some measure that you put next to information about the car that you're selling, the state of health of the battery?
Yes. Sorry, if I may, yeah, definitely. So now in the second-hand market cars, you take care of the general state of the car, and also a big parameter is the kilometers. So that's huge, and everybody knows. So the equivalent of the kilometers for the battery will be the state of health. And also translated, and also Nicolas said that, to how many kilometers of autonomy gives me this car. So it will be a really easy calculation that also the dealer can do. What is the original with the 100% state of health autonomy, and what is the current state of health, and then you give the autonomy kilometers for the potential buyer. So this is something that we are seeing that the customers of EV cars are getting used to, and this won't be one of the biggest factors in order to decide if you want to buy this EV pre-owned car or not.
Thanks, Oscar. So I understand that also in the future, any second-hand car markets, they should have such a feature. The question is probably who would be verifying this. But fortunately, we have certification bodies like Cara Group, for example. And so curious to see the developments there. And I think these were all the questions in the chat. Maybe now, just like the last time, we can invite everyone also with your cameras. I think we can maybe stop the recording for this last section, or actually before that, maybe Rose, we can first show what comes next. Because we're happy to announce that we already have the next event. Maybe you've received a notification from the community platform on the 28th or 27th of May. We'll have an event on battery dismantling in reverse logistics, and here we want to touch upon quite interesting topics related to the depth of this assembly of the packs. What is the economically viable option for dismantling? What are different methods for automating the battery dismantling? And we'll have some speakers both from our project, but also from some experts in automatic battery dismantling from outside of the project. So you are all invited to join. And with that, I think we can still do a poll, which I will open shortly. Okay, relaunch. Great. At the end of this meeting, we wanted to ask you what other topics related to reverse logistics you would like to learn more about in the future. Based on that, we can also plan ahead some events that will interest you most. So please answer our poll. You can also in the second question write down some other ideas that we haven't thought of. Okay, we have quite many people interested in battery repurposing, battery passport, and data management. You will soon see the results as well. But let's think 3 more people. Okay. I will share the results with you. We have quite a lot of interest on battery trading and battery repurposing, passport, transportation, and storage. And we'll definitely cover these topics in the coming versions as well. And now I think we can stop the recording. So thank you again, everyone, for coming. And